There will be a presentation of the team NOx with the title Proposed Revision to Reflect Requirements of the Operation for the SCR Recording Device. Everyone, please welcome Team NOx.
Hello, we are Team NOx.
At first, we are going to talk about NOx emissions from ammonia engines.
Ammonia engine produce higher NOx than diesel engine, so it proposes the continuous SCR operations.
In order to find solution, we will be referring to MARPO regulations and SCR guidelines in the upcoming sections of this presentation. Thank you very much.
Good afternoon, honorable judges and distinguished delegates, ladies and gentlemen, we are Team NOx. Following the IMO net zero policy, we propose continuous SCR operation to reduce NOx emissions from ammonia engine. Background is overview of IMO's decarbonization strategy, ammonia use risk, and SCR for NOx reduction. Problem analysis is need for continuous SCR operation and clear NOx regulation for ammonia engine. Solution is continuous SCR operation during ammonia engine use. Conclusion is discussion of limitation and anticipated point. Then I will start with the background. International shipping handling 80% of global trade is a major source of greenhouse gases. In 2018, the IMO set an initial strategy to cut greenhouse gas emissions by 50% by 2050 compared to 2008 level. Then, in 2023, the IMO introduced greenhouse gas reduction strategy aiming for 40% reduction in CO2 per transport work by 2030 and achieving net zero greenhouse emissions by 2050. As a result, there is a growing need for low carbon and zero carbon fuel. According to the shipping energy consumption graph, ammonia fuel use is expected to rise by 44% by 2050, reducing carbon emissions. With high CO2 reduction potential and fuel technical barrier, it stands out as a promising alternative fuel. Is ammonia without issues? No, there are significant issues. Burning ammonia produces nitrogen oxide, which are harmful. Its combustion results in higher NOx emissions than traditional fuel. From a health perspective, NOx can damage lung structure due to its low water solubility and ability to spread to respiratory system. Environmentally, ammonia combustion generates nitrous oxide N2O, which is 265 times potent than CO2. Even a slight increase in N2O can greatly impact overall greenhouse gas emissions. Additionally, ammonia slip refers to release of unburned ammonia slip combustion, posing risk to both health and the environment. Thus, it is essential to reduce NOx emissions. Then, how does ship reduce NOx emissions? The answer is SCR system. SCR stands for Selective Catalytic Reduction. It reduces nitrogen oxide in exhausted gases by reacting them with a reducing agent called urea and a catalyst. The purpose converts NOx into harmless nitrogen and water, helping to prevent environmental pollution. According to MARPO 6 Regulation 13, ships entering or changing operation in NECA area must record this in the electronic logbook, as NOx emissions are strictly regulated there. Currently, SCR regulation apply only to diesel engine, with no specific guideline for using ammonia fuel. Now, next presenter will explain this in more detail.
Hello everyone, first I appreciate previous presenters for the background explanations. I'll be presenting the problem analysis in detail. When using ammonia engine, applying current regulations could meet problems. To analyze this issue, first we need to understand the concept of emission control area. According to MARPO Convention Next 6, there's two main types, Tier 2 and Tier 3. Tier 3 sets NOx emission limits for navigation in emission control area, while Tier 2 applies outside this zone. And Tier 2 has reduced NOx limits by 15 to 20% compared to Tier 1, while Tier 3 is 80% stricter. Existing vessel can meet Tier 2 requirements with minor engine adjustments without the SCR systems, but Tier 3 compliance requires the SCR system to lower NOx emissions. However, ammonia cannot meet Tier 2 regulations without the SCR systems. Ammonia is gaining attention as a fuel, but it produces higher NOx than fossil fuel. If ship owner chooses ammonia engine, the SCR system will need to operate continuously to meet both Tier 2 and Tier 3 standards. MIT also demonstrated the necessity of SCR in all areas for the use of ammonia engine. The goal of this study was to determine whether NOx emissions from pure ammonia engines could meet Tier 2, Tier 3 standards. According to MIT 2020 scenario based on IMO Tier 2 and Tier 3 standards of 2020, pure ammonia engines meet Tier 2 requirements without SCR, but require SCR in Tier 3. However, for ammonia hydrogen engine, the SCR must operate continuously to meet both Tier 2 and Tier 3 standards. In the chart, the left shows NOx emissions from pure ammonia engine, and the right shows NOx emissions from the ammonia hydrogen engine. And also, the red bar shows NOx levels from the engine exhaust, and the blue bar shows levels after SCR. As we can see, pure ammonia engines produce about 7, and ammonia hydrogen produce about 32 grams per kilowatt-hour without the SCR. In contrast, from this, we can observe that pure ammonia engines meet Tier 2 requirements without SCR. In contrast, ammonia hydrogen engine produce much higher NOx emissions, requiring continuous SCR operations to comply with IMO tier standards. But can we avoid SCR entirely with pure ammonia? Not quite. Currently, pure ammonia engines are not feasible due to their low flame propagation speeds, necessitating a mix with LNG or hydrogen. The table here illustrates the laminal and adiabatic flame speed at a different ammonia ratios. As ammonia percentage increase, the flame speed drops sharply. This makes pure ammonia unsuitable for ship engines, meaning an ammonia dual fuel engine is necessary. Therefore, ammonia dual fuel engines, such as ammonia hydrogen engine, become essential for real-world applications, even though it requires continuous SCRs to meet both Tier 2 and Tier 3 standards. This brings us to regulatory gap in NOx reduction standards. SCR has no specific NOx reduction standards like those for sulfur oxide with scrubbers. For SOx, IMO mandates that scrubber meet strict sulfur content level. To ensure compliance certification, the scrubber must meet continuous SOx monitoring with measurements taken at precise interval. These requirements exist because scrubbers are operated continuously, and certificates are issued based on capacities to meet SOx standards throughout operations. The solution for this will be explained by next presentation.
Thank you, ladies and gentlemen. I will introduce solutions regarding ammonia engines. In this section, I will propose 2 amendments. First, we will address MARPOL Annex 6, Regulation 13 concerning NOx emissions. Second, we will discuss MEPC 71, which provides guidelines on SCR systems. Lastly, I will explain why we reference scrubber guidelines in support of our proposed amendments. Before introducing our proposals, it is essential to note that this document aligns with Strategic Direction 2 and Performance Indicator 2.1. These are related to PPR subcommittees and specifically the MEPC work. Under the initiative titled Advancing Technologies in the Regulatory Framework. Now, let me introduce our proposals. Please focus. First proposal, we propose an amendment to MARPOL Annex 6 Regulation 13 on nitrogen oxides, specifically regarding Section 5.3. Currently, Section 5.3 applies to marine diesel engines, mandating SCR activation only within NOx Tier 3 emission control areas. It also requires records of the SCR, on-off status, date, time, and location. However, since ammonia engines require continuous SCR operation to meet Tier 2 NOx levels, we propose a new section 5.3.1 specifically for ammonia engines. This new section should mandate continuous GNSS-based location tracking to verify SCR operation at all times. Second proposal, we propose an amendment to the SCR guidelines, MEPC 71. To ensure continuous SCR operation, the guidelines should establish requirements for automated data recording to prevent tampering or human error. We propose adding a new Chapter 8 about data recording and processing device. Following the sections. First section, 8.1, mandate a tamper-proof design to eliminate human error. The second section, 8.2, require GNSS-based position tracking for continuous location logging whenever the ammonia engine is activated. And third section, 8.3, specify the data should be recorded at a frequency of at least 0.0035 Hz to ensure detailed operational records. And to support these sections, further discussion on monitoring and sensing devices for NOx emissions detection will be necessary. Then, you may wonder why we propose adding these specific regulations. Consider this. This regulation might seem familiar as they already exist in the scrubber guidelines. At MEPC 77, regulations are set for ships using high sulfur fuel, requiring them to meet ratio emissions through an EGCS, also known as scrubber system. Due to these regulations, ships must use a data recording and processing device to verify EGCS operation. The key requirements for EGCS operation include following sections. First section, 5.4.2, continuous data logging at a rate faster than 0.0035 Hz. And second section, 7.1, a tamper-proof design to prevent data manipulation. And third section, 7.2, GNSS-based location tracking with time-stamped records. And final section 8, onboard monitoring manual called OMM to prove compliance using a monitoring system that might expand to include NOx emission sensing. These established standards are why we reference the scrubber system guidelines in our proposal for continuous SCR operation. Then, you might ask, are there any limitations or potential challenges with our proposals? Yes, identifying these limitations is essential for a balanced approach. That is why, in the conclusion, I will highlight the anticipated limitations and key points we need to address. According to MAN Energy Solutions, ammonia engines can meet Tier 2 standards without SCR. Given this, you might think our proposal is unnecessary. However, reducing NOx emissions directly from ammonia engines often means sacrificing power output, especially for smaller engines. Additionally, reduced power can lead to increased fuel consumption. Thus, ship owners face a choice between installing SCR to reduce fuel consumption or not installing SCR and consuming more fuel, a decision that impacts both CAPEX and OPEX. This trade-off warrants further discussion under IMO Performance Indicator 3.3. Moreover, while ammonia engines offer over 95% reduction in carbon fuel, they do not achieve zero carbon due to the need for dual fuel operation. This aspect should be discussed under Performance Indicator 3.5. Lastly, if I summarize our presentation, I can say continuous operating SCR is our key amendments whenever ammonia engine is operating. Finally, these are our references we have used. Please feel free to ask any questions and we will respond promptly. Thank you very much for your continuous attention.
Thank you so much. I appreciate NOX for their nice presentation. Okay, there will be a Q&A session. I'd like to invite judges for questions first. Okay, if any questions about this presentation, yes, please.
Thank you very much. Thank you for your very technical presentation and papers. Actually, I think it's very timely proposal because ammonia or hydrogen is very essential fuel for IMO's GHG reduction strategy. So it's very good approach. My question is that your proposal is in this document is based on a university study. So I would like to ask you that is there any other information paper or studies? That's my first question. And the second one is how can we combine or how can we limit the SCR is the only way to comply with NOx regulation in MAPL Convention? That's my second question. Thank you.
Okay, first of all, thank you for your questions. You have asked, is there any graphs or documents or referencing other studies? Yes, there is, but we want to reference that not even the university or engine makers like MAN BMW, Wärtsilä, and Wingery, they are saying, can we move the slide? Yeah, following the MAN Energy Solution, they have to, they don't have to use SCR when they establish the ammonia engine. You can see the red lines of ammonia engine. Here can be admitted by only ammonia engines. But in MIT paper, they have to use SCR for reducing NOx emissions. So actually, the document by document are different, the graph and the numbers. So actually, it is just a prediction. It needs real-time trial in ship environment. We have to check first, and then we have to discuss further amendments. Yes, there is limitations. That is first question's answer. And secondly,
okay, there's other ways to get rid of the particle matters that called nitrogen oxide. And one of the way we can use the NH3 scrubbing. The first one, the NH3 scrubbing systems to get rid of all particle matters and emissions produced all by the ammonia. In my presentations, okay, this one also mentioned about the NH3 scrubbings in other scenario, but I didn't mention about this because this one also focused on NOx reduction. NH scrubbing also focused on NOx reduction, but they address the emissions other than just NOx, including ammonia. So they're not suitable for explaining only for NOx, but this is one of the way to get rid of NOx.
yeah, I have more adding comments. You have asked the SCR is only requirements for reducing NOx emissions. Actually, yes, there is only ship is in SCR is only exist. Then you can ask the degree of NOx. How much SCR can reduce NOx emissions? You can ask. Then we can answer, yes, by using more urea or catalytic system, we can reduce more NOx emissions just using SCR. Thank you.
Okay, thank you. Your answer.
Thank you. And any more questions from the judge? Let's move on the floor. Are there any questions about this presentation? Please raise your hand. Okay, team raise, please.
Thank you for good presentations. It was so impressive. I have some questions. As far as I know, the SCR used the denitrification catastrophes. Which denitrification catastrophe will be used to reduce the NOx in ammonia fuel? That is my questions.
I'm sorry, but I cannot understand your questions. Could you repeat again? I'm sorry.
SCR used the denitrification catastrophes, which denitrification catastrophe, what kind of catastrophe will be used to reduce your NOx in your ammonia fuel?
So you asked what kind of catalyst in SCR used?
Yes, that's right.
Yes, it's very simple questions. Can you move the slide? Okay, we have only one catalytic materials. It's called urea, and urea is consist ammonia and water solutions that is dissolved. By spraying in the SCR system, the urea is dissolved to ammonia and H2O. By result, the ammonia is represent as H2O and hydrogen. So I can answer your question. Only urea exists for marine SCR. Thank you.
Thank you. And are there any questions on the floor? No one? Okay, what about the judges? Any comments or recommendations to this team? Yes, please.
Yes, thank you for your presentations. To the with regard to the ammonia, the fuel oil, and so when we make it to the green ammonia, and so it is important that we get the solutions to the methane slip. So could you explain to the methane slip, ammonia slip, how to solve that problem, maybe during the operation?
Okay, your question is how to reserve the methane slip.
No, the ammonia slip.
Ammonia slip,
Yeah.
okay. Talking about ammonia slip, actually it is impossible because it is gas fuel. Talking about liquid fuel, we can prevent because it is a liquid fuel has a system that can be returned to the fuel tank, but in case of gas fuel, we cannot be returned, only exhaust to the atmosphere, so we cannot be avoided. But like a sealing from the cylinder or piston, we can partially prevent it. But I can say, with now technology, the internal combustion must be activated in the cylinder, so we cannot 100% prevent the methane slip, even though we use dual fuel. Thank you very much.
Yeah, okay, I got it.
Thank you, and I think we can get one more question. All right, Team Icebreaker.
Thank you for your presentation, and I presume from your presentation that this SCR device was not in action when the ammonia ships first came out. So there are in the world out there ships which have ammonia engines and doesn't have any SCR systems, right? And that means how costly is it to insert an SCR system into a ship?
Your question is how much cost when we install SCR in ammonia engines? Actually, I mentioned before, there is no any data, so we have to just reference the papers or other documents. you have to choose when you are ship owners. Yes, there is the more cost effective when installing SCR, but even though you didn't install SCR, you have to use more fuel. So I have mentioned in my presentation, you have to think about the CAPEX and OPEX by installing SCR or not installing SCR. You have to think about when you are ship owners. Thank you.
Okay, the time is up. Let's wrap it up here. Thank you. Knox, you may go down to your seat. Everyone, please give them a big round of applause.